developer, the operations, or whatever your role is, can send off that workload definition, hand it on over to the Kubernetes API endpoint. Azure will take care of it and then schedule it accordingly to your agent pool or your worker nodes. Simple, right? Now let's do a quick refresher also on how container layers work. And this is important when we consider that container security. You're always going to have a base image. In this instance or this example, we have from Alpine. And then each blue block that you see or each block building on top of that is a layer. That's usually a line in your Docker file. All of those layers that gets baked into your image are image layers. They're read-only. Your read-writes actually happen at the container layer when you're running your container, be it you're running it in Docker or Kubernetes. But people forget, and even I've forgotten sometimes, that anything that's in your read-only is accessible at that container layer. That means things like your database connection strings, your SSH key pairs, your plain text passwords. So there's certain things that you want to consider as you're dealing with this, again, container building process. You can think of it kind of like a cake or a stack of waffles. And I like to compare containers to a waffle because all waffles do, in reality, is they're delivering some sort of happiness or joy. If you take the breaded part of a waffle and you just have it completely plain, chances are it's not going to deliver as much value, unless that's your preference, and that's great, but as much value as if you start adding value-add toppings. You add whipped cream, you add syrup, you add strawberries, blueberries, pecans. All of those different toppings are value adds. You're being very intentional with what you're putting on that waffle, and that waffle now becomes a delivery mechanism for that happiness or that positive end user experience. That's the same thing that a container is. But if you have a stack of waffles or a stack of cake as you see on the screen, you need to be very careful what you're baking into that cake or into that waffle. Okay, this is where it just kind of becomes very important to consider that, to be very cognizant of that throughout your build process. So in this next demo, we're going to learn how we can do just that, how we can be very intentional and how we can build secure containers.
All right, so in our last demo, we saw that we have quite a bit of vulnerabilities that Azure Security Center helped us identify. So now we're going to take a look at the source itself and see how we can start fixing some of those. So the first API I'm working in, and we can actually drop down, you can see that I have Tailwind Traders backend open here. I'm in the source directory. You can drop down into services, and I'm currently working in the cart API. We have all the different APIs here, so we can start working in cart and coupon and image classifier. But I just want to change a few of them just so you can kind of see what we're going to work with here. Here's our Docker file. It starts out with our from image, which is kind of like our base image. We set a work directory, which is the folder that we want to work within our container. And remember, a container is not a virtual machine. A container isn't even a real thing. All it is an application delivery mechanism with process isolation. It's just going to help you deliver your application in the most valuable and safest, secure, most optimized way possible. But that kind of is dependent on you and how you structure your Docker file, right? You have to make it secure. You have to make it perform well. So we have to do things that's going to be optimal for our application delivery. So you can see our work directory, we're copying our package.json file over. This is obviously a JavaScript component of our application. Like I said, it's both coupled as React and .NET Core, but it doesn't matter the language. It matters, again, the structure of that application or that process isolation delivery system. So after we set up our packages, get any of our build dependencies, Python files, we copy our files and everything over, we're then gonna run just our normal npm start command, and that's what we defined in our package, package.json. So right before we actually start our container itself, right before we run it, we're gonna add in one line that's called a user. And this is where we can set the actual user name that we want this to run as, or we can set the user level. If we set that user level to 1000, that's just a standard default non-root user, and that helps set us up to make sure that this container is not going to run as root. It's not going to run as a super user, and therefore it won't be flagged in Azure Azure Security Center as a potential vulnerability. The other benefit for this is when you do have containers that run as root, they have the potential, in the event that there's malicious code in your application, of actually jumping out of the container and attacking the host. That is a little specific to Linux containers. If you're working with Windows containers and you have Hyper-V isolation, sometimes you have an additional level of security, but rather than focusing on the architecture from a